Hello everyone, myself Sadananda Gowda. Today I am going to explain problem solving NFA conversion to DFA. Conversion of NFA to DFA. Method 1. Conversion with epsilon moves. One way to convert an NFA to a DFA is by considering the epsilon moves. This method involves capturing the states that can reach us through epsilon transaction and combining them to form new state in the DFA. This process ensures that the DFA accounts for all possible states and transactions, including the epsilon moves present in the NFA. Method 2. Conversion without epsilon moves. Alternately, the conversion from NFA to DFA can be performed without considering the epsilon transaction present in the NFA. This method typically involves that creating a transaction table that includes all possible combination of states the NFA and identifying the transaction among these states. While approach may be more straightforward, it may be resulted in a large DFA. Method 1. Conversion with epsilon moves. Complexity analysis. When converting an NFA to a DFA with epsilon moves, it is essential to analyze the complexity of the resulting DFA. The number of states and transactions in DFA can significantly increase due to the inclusion of epsilon transaction. Understanding this complexity is crucial for evaluating the efficiency of the conversion process. State combination. During the combination, identifying and combining states that can be reached through epsilon transaction plays a key role. This process involves creating new states in the DFA that capture the combined behavior of the original NFA states, accounting for the non-deterministic nature of the transactions. Determining enforcement. One of the primary objects is to enforcing determining in the resulting DFA. It in ensuring that each state the DFA has a unique transaction every symbol in the input alphabet. Addressing a non-deterministic in the NFA is a critical aspect of this conversion method. Method 2. Conversion without epsilon moves. Transition table construction. When converting from an FA to DFA without considering a epsilon moves, constructing a transaction table become a fundamental part of the process. This table captures all possible combinations of states from the NFA, indicating the transaction for every symbol in the input alphabet. State identification. Identifying the state in the resulting DFA is a significant aspect of the conversion method. Each state in the DFA represents a unique combination of the state from the original NFA. Understanding the role of the each state in recognizing pattern is crucial for this identification process. Minimization of considerations. Considering the minimization of the resulting DFA is an important optimization strategy. The size of DFA obtained with considering epsilon can be large and minimizes the number of states can lead to more efficient pattern recognition and memory utilization. Examples of converting NFA to DFA. Initial NFA, a visual representation of the initial NFA showcasing its states, transaction, and the presence of alphabetic moves in any. NFA to DFA with epsilon moves. An example illustrating the step-by-step conversion of an NFA to DFA, including the specific handling of the epsilon transaction in the process. NFA to DFA without epsilon moves. And another example demonstrating the conversion of an NFA to DFA without considering epsilon transaction, outlining the methodological creation of resulting domestic automaton. Consider the example. First, identify equivalent state. Determine which states in the DFA are equivalent. Two states are considered equivalent if they lead to the same set of states on the same input symbols. Partitioning. Partition the set of states into group of equivalent states. Initially, each state is in its own group. Refinement. Define the partition by merging equivalent states into single representative states. This process continues until no more mergers can be made. Fourth, updating transaction. Update the transaction of minimization DFA according to the merged states. Fifth one, the final DFA. Construct the final minimization DFA using the merged states and update transaction state. Sixth one, optimization. Optimally perform further optimization such as removing underreachable states or redundant transaction to improve the efficiency of the minimization DFA. These steps may slightly depending on the specific minimization algorithm being used, but they provide a general framework for the process. This is the transaction diagram. Thank you. I hope you all understand.